Problem number 3. So we have our reference angle definitions. Sine of theta is y divided by r. Y is the y-coordinate of the point on the terminal side. R is the positive distance from 0, 0 to that point. Well, sometimes sine theta comes out positive, sometimes sine theta comes out negative. It really depends on the quadrant. Now, if you think about it for a minute, the r is always positive, so that's not really going to have an impact. It's really going to all be determined by the location of the y. So if I'm in quadrant 1, if I'm in here somewhere, that's going to have a positive y value, that point, which means the entire ratio is going to come out positive. Similarly, if I'm in quadrant 2, maybe this is the point -3, 4 or something like that. But once again, if I'm up here, the y value is positive, which means the entire ratio is going to come out positive. On the other hand, once I move down into quadrants 3 or 4, you can see that those points have negative y coordinates, -3 or -4 or -5, which means the entire ratio will come out to be negative. We're saying sine theta comes out positive in quadrants 1 and 2 and negative in quadrants 3 and 4. Problem number 4. I've got a couple of special triangles here. I'd like to fill in the missing sides. When I look at part A, I have a 45, 45, 90 triangle, but it's not the basic one. The basic one goes 1, 1, and then square root of 2 for the hypotenuse. I don't have that here, so I'm going to have to rely on the more general form, which is x, x, and x root 2. Well, they've given me the x root 2 side. They've told me that that's equal to 1. I can use that then to figure out x. In fact, I can solve for x in just one step. Just divide both sides by square root of 2. And I have now figured out that the x in this picture must be 1 over square root of 2. I do want to give simplified answers, so I'll rationalize the denominator. But I'm finished. X is equal to square root of 2 on the top, and then root 2 times root 2 is 2 on the bottom. So each leg is square root of 2 over 2 units long. In letter B, I have a 30, 60, 90 triangle. Again, it's not the basic one. In the basic one, the hypotenuse is 2. So I'll have to use the more general labeling. The general labeling is x for the 30-degree side, x root 3 for the side opposite 60, and 2x for the hypotenuse. They have given me the fact that the 2x side is equal to 1. So I can quickly here solve for x. I get x is equal to 1/2. Well, that's really all I need to know to figure out the rest of these sides. The short side right here is x, so x is 1/2, we've just figured out. And the y side, the medium side, the second leg, the one opposite the 60, is equal to x times the square root of 3. That's how 30, 60, 90 triangles work. If I take 1/2 times the square root of 3, I'm going to end up with square root 3 over 2. So there are the missing lengths that we were looking for. In problem 5, we're just being asked to type these things into the calculator and get some decimals. The first one is square root of 2, and then leave the square root divided by 2. That is about 0.707. And then we want to do square root of 3 over 2. I think I'll just take my last entry here and scroll over and change that 2 to a 3. And now I have square root of 3 over 2. And that is about 0.866. The next one is 2 pi. You probably know that pi is around 3.14. 2 pi is around 6.283. And then pi over 2, in other words, just half of pi, that comes out to be about 1.571. Problem number 6. If the sine ratio for an angle is 2/3, what do we know about the cosecant ratio? Well, cosecant is just the reciprocal of sine. So if sine is 2/3, the cosecant ratio then is 3/2. Letter B, what if all we knew was that the sine ratio comes out negative, it's less than 0? Can we say anything about the cosecant ratio? Well, again, it's just the reciprocal. When you reciprocate a negative number, all that happens is the top and bottom switch places, so the sign, S-I-G-N, is not going to change. If the SIN sign ratio is negative, then the cosecant ratio will also be negative. Problem 7, I'm given an angle there, beta. It's drawn in standard position. I see a point there on the terminal side, and I want to fill in the 6 trig ratios. Well, I have my x, I have my y. The only thing I'm missing is my r, my distance from 0, 0 to that point. It's generally helpful to drop a perpendicular to the x-axis, forming a little right triangle. In fact, I can label this as -5 here and 12 here. To determine the r, just use the Pythagorean theorem. So -5 squared plus 12 squared equals that r squared, r being the hypotenuse. This is 25 plus 144, which equals 169. And this one actually comes out nice. When you square root both sides, square root of 169 is equal to 13. Remember, r is always positive. It's a positive distance. Now that I have my x, my y, and my r, I can fill in my definitions. In fact, if I consider this reference angle here, I can even just use SOHCAHTOA. Sine is y over r, so 12 over 13, or equivalently opposite over hypotenuse. Cosine is x over r, -5 over 13, adjacent over hypotenuse. Tangent is y over x, so 12 over -5. We generally like to put our negatives in the front, so I'll write -12/5. Or I could use SOHCAHTOA, opposite over adjacent. And then the other three are just the reciprocal values. So cosecant is the reciprocal of sine, 13 over 12. Secant reciprocates cosine, so -13/5. And cotangent reciprocates tangent, -5/12.